Hello, and welcome to our discussions on the link layer. In the previous module, we explored the network layer and learned how finding a path and forwarding the packets along that path from source to destination happens. A network layer datagram traverses along a series of links between the nodes from source to destination. In this module, we will learn how each of the links in that path that this packet traverses might have a different set of characteristics. Some links are wired, some are wireless, some are within a local network, and some connect us to a router port to go to a different network. Some connect 2 points, and some, like Wi-Fi, seem to be shared among all users within the range. So, how do each of these settings work? We call the packet for the application layer a message, that of transport layer a segment, and that of network layer a datagram. We call the link layer packet a frame. A frame encapsulates a datagram for transferring it from one node to the physically adjacent node. The service of the link layer is that of delivering the frame over a single link. What is involved in sending a frame over a link to the next physical neighbor? Each link has a different set of characteristics. This means a different link layer protocol for each link. A packet might go over many different links on the end-to-end path from source to destination. It might go over an 802.11 in the first link and Ethernet on the following links. This means frames and the protocols of their transmission might be different for each link along the path. An analogy in a real world might be taking different means of transportation on a travel. For example, you want to go on a trip to a different city. You might take a taxi to the airport, then the airplane to a city near your destination, then a train to the destination city, and finally a taxi from the train terminal to your hotel. Similarly, each link layer protocol provides different services over a link. For example, a protocol may not support reliable data transfer over a link. Or some links might be half duplex and others full duplex. Full duplex means two sides of the link can receive and transmit at the same time. In half duplex, nodes at both ends of the link can also transmit, but not at the same time. We said the link layer protocols for each link type are different. The services provided for each link layer protocol are also different and tailored to the specific link type. Framing and link access are the common general services. Framing is encapsulating the datagram into a frame with adding the required headers and sometimes trailers. Headers are the fields preceding the datagram, and trailers are the fields following it in the bit sequence. Link access is another common service. This includes management of sharing if the link is shared, and addressing for devices involved in the link access. Another service provided by link layer is error detection and correction. This is done in the link level, so that if a frame is received with bit flips, it is detected, and it's not sent forward like that. These flips happen due to physical layer phenomena like noise and attenuation. Although similar in concept to checksum that we previously learned about, error detection and correction in the link layer is usually more detailed. Sometimes, with use of additional information, correction mechanisms are also applied. Reliable delivery mechanisms, similar to what we discussed in general RDT mechanisms, are also provided in some types of links that have higher error rates. Although might not be necessary for links over copper or fiber, these are usually implemented for wireless links. Flow control, which is pacing the rate among the sending and receiving nodes, may also be provided in some link layer protocols.